All right, we got one more problem to do. And I went ahead and put this on a new page so I actually have room to write this out. And there's one thing I want to mention before we start this problem. I know I have everything here written out in steps, but that doesn't necessarily always mean you have to follow those steps exactly in that order. I mean, realistically, steps 3 and 4 could be interchanged. But sometimes I think it can be helpful if we approach these problems in terms of steps. But as long as you reach your goal at the end, right? That's all that matters. Okay, so let's take a look at this problem, highlight as we go. An engineer designed a valve that will regulate water pressure on an automobile engine. The engineer designed the valve such that it would produce a mean pressure of 5.0 pounds per square inch. So remember that keyword designed. That means this product was built to perform at this level. So this is what we're going to be using for our null hypothesis once we actually write that out. It is believed that the valve performs above specifications. The valve was tested on 18 engines. 18, that's a small sample size, big sign that we're going to be using the t-test statistic, with a mean pressure of 5.1 pounds per square inch. I'm sorry for the overlap in highlighting here. With a variance, I did not purposely pick 3 problems with variance, but I guess it just happened that way. With a variance of 0.64. And then we're going to use a level of significance of 0.01. And then we're going to perform a hypothesis test, see if we can reject or fail to reject this null hypothesis. So let's write out the null. So once again, the null is always mu equals some value. And this is what we assume to be true. And they designed the valve to produce a mean pressure of 5.0 pounds per square inch. So mu is equal to 5.0. That's our null hypothesis. But it's believed that the valve performs above specifications. So we're going to have mu again. Let me fix that mu. That one's looking a little crazy. I hate when it changes to it. There we go. Okay. Sometimes it changes to that little black arrow cursor instead of this little dot. I prefer the dot. And I put equals. Should not have put equals. Above specifications. That's greater than, right? So mu is greater than 5.0. So we have our null and alternative hypotheses ready to go. What was our level of significance? We call that alpha again. It's 0.01. It's going to be that's the area in the tail regions. Number 3, if we're following the steps in order as I've presented them, which again, you don't necessarily have to do that when you're working out these problems. We're going to select the appropriate test statistic and compute it. As discussed, this is definitely going to be a t. We have a small sample size, and they're giving us the sample variance, which will give us the sample standard deviation. So population standard deviation is unknown, and we have a sample size less than 30, so it's definitely a t. I'm going to write out the information one more time just before we plug it into the formula. Our sample size was 18. X bar, that's our sample mean. That was 5.1. That's from the sample data. Again, they give us variance, which is S squared for the sample, and it was 0.64. Take the square root of that. The sample standard deviation is going to be 0.8. All right, let's plug it in. So t is going to be equal to our sample mean minus the sample standard, minus the population mean, which is what we get from the null hypothesis, divided by the sample standard deviation. And that's divided by the square root of our sample size, 18. So once again, pop that into a calculator, and I'm rounding to 3 decimal places. So I'm probably gonna put a approximately there. 0.530 is going to be our test statistic. Now let's check out our critical values. Once again, I'm writing CV here. We could also use T star to represent the critical values. However you want to do it, it's just notation. So before we find that, we need to make sure we have all the proper information. We need degrees of freedom, which is your sample size minus 1. So our degrees of freedom is going to be 17. And then you need to know if it's a two-tailed area or a one-tailed area. And since we're looking at greater than, we are going to have a one-tailed area. So a one-tailed area of 0.01, because that's the significance level. That's our area. All right, I'm going to pop over to my t-table. You, if you're in Hawks, would click on the one-tailed area for the t-table. So one-tailed area, and I need 0.01, so I'm all the way over here. And then our degrees of freedom was 17. So I'm going to go down till I find 17. Here we go. 2.567. All right. Critical value is 2.567. Now, just to draw a picture, double check where this is living. This is going to be on the right side, right? Because we're checking if our alternative hypothesis, well, the alternative hypothesis states mu is greater than the population mean 5.0. So our critical value is going to be on the right side, which means it is going to be a positive number, 2.567. And if our test statistic lives beyond that, if it's greater than that value, then it'll be in the rejection region. If not, it'll be in our failed to reject region. So let's write out the decision rule, which just tells us when we reject. We're going to reject the null if T, our test statistic, is greater than or equal to our critical value, 2.567. So let's check it out. Is 0.530, that was our test statistic, is that in fact greater than or equal to 2.567? No, not at all. 0.530 is going to live, again, pretty close to the mean compared to 2.567, right? So we are going to, we fail to reject the null hypothesis. And another quick thing, this little statement I write out here is 0.530 greater than or equal to this critical value. You don't necessarily have to write that out. I'm just writing it out because I'm teaching and I want to make sure everyone's clear at what we're looking at. But that's not always a required part of the process. But this decision rule that we wrote up here, you know, if you did the homework from 11.2a with the Z testing, the Z hypothesis testing, then you might have already seen that sometimes the problems ask specifically for the decision rule. So I think it is helpful to write this out every single time when you do these problems, but it might not always be necessary to write out this part. However, if it helps you actually visualize, you know, what's going on with these values, then by all means, write it out, right? Whatever will help you get to the right answer. Do what works for you. Okay, so we failed to reject. So how can we rewrite write this in terms of the problem? We would say that there is not sufficient evidence. I'm putting suff for sufficient. evidence to support the claim that the valve performs above specifications. All right. Yay, that was our last problem. So all the homework from this section is going to focus on, the T, test statistic. Now, once again, once we get to the final, everything's going to be mixed up, right? So you do want to know the difference, and you want to be able to recognize when you have to use the Z test statistic and when you have to use the T test statistic, similar to when we were building the confidence intervals. You have to know and be able to recognize when to use which. All right, if you guys have any questions, please let me know. Good luck in your studies. And if you want to see another video or two, even if it's on older topics from the semester, please let me know and I can definitely post some more videos for you. Have a great day.